So in this module, we're going to be talking about implementing sorting algorithms in Java. So before we actually see how we implement the methods themselves, I want to talk about a few helper methods that we're going to use, first off to actually implement our sorting methods, and then to test our sorting algorithms. So the first three methods here, less than, equal, and greater than, are intended to help us write code that's a little cleaner. When we do a.compare to b, it's not really clear straight off exactly what we're doing. And so to simplify the way that looks in the code, we have these helper methods that let us just say what the comparison is we're doing and the two objects we're doing that comparison between. And you may wonder why there isn't a greater than equal. It's solely because none of our actual sorting algorithms use that particular method. If we find a place where it's helpful, we can always come back and add that. The next method that we're going to be using is swap. And the purpose of swap is to give us a one-line method call that swaps two locations in an array. So you can see here we create a temporary variable called swap where we store the element at index ii. We move the object from index jj into index ii. And so then we copy the original object back into index jj. So again, this is just to clean up our methods so that instead of having to do these three lines each time, we can just call this method to swap the elements at two locations in an array. So these are the helper methods that we're going to be using to implement our sorting methods. And these are two methods that we're going to use to test that our sorting methods actually work. isSorted takes an array of comparable objects as its parameter, and it checks that everything between index 0 and index length -1 is sorted. And so you can see here that we go from min plus 1 to index max, and this is inclusive. And in this method, we're trying to make sure that each pair of objects is relatively sorted. And if we find one that's out of order, then we return false. Otherwise, we return true if we succeed going through here, comparing every pair of elements to be sure that the first one is smaller than the second one. And you may say, well, how can we get away with just comparing two at a time? If the array is sorted, then there won't be a case where two elements are out of order. But if it's not sorted, at some point in the array, we have to have a smaller object that comes after a larger object. So wherever that happens, this condition will hold and will return false. So to test our code, the first thing is I have an enum type that indicates each method we have. In a loop, we're going to generate a random array, and then depending on which of these enum types are set here, we'll call the appropriate sorting algorithm. And then we'll also print the array before and after we sort, just so that we can see what happens. And this print array function, again, just takes an array, and for each element in that array, it prints it out on a single line. And then to make sure that each of these is correct, we check to see, once we've completed sorting, is the array actually sorted? And if it's not, we print fail and we increment the number of failures. And then once we're done, we say whether or not the test was successful. So you can see here we have our algorithm set to selection sort. And if we run, you can see that it sorts a whole bunch of random arrays. And then when we scroll down to the very bottom here, it was successful. There were 0 failures. All of these arrays were successfully sorted. And you may wonder, why are we doing this 50 times? And the reason is because we could, in theory, generate a random array that's already sorted. So we could have a sorting method that was terrible that only just returned the array, and it would look like it was sorted and working. And so the other reason is that there's little things that can go wrong in different types of arrays. And so we hope that the more random arrays we generate and test with, the more likely we are to get one that actually works. So that's the code that we're going to be using to implement and test our sorting methods. And in the next videos, we'll cover specifically the implementation of different sorting algorithms.